Hi, welcome to the Lux channel. So when you are working on network software development, and especially when you are doing some research, time to time you may need to do some custom protocols. So sometimes you may have a proprietary network stack, and you may sell that stack to your customers. I often seen many companies do that. So as a reference, they do this stack on in a user space, and it can be ported into a kernel if required. It's just not about Linux kernel. It can be any kernel. Sometimes it can be a microkernel embedded board platform. Sometimes they may even get some customer where they may buy this stack, and this stack can be anything. It can be a custom TCP/IP stack, it can be a custom layer 2 slow protocols, or some type of routing protocols, or anything like that. Okay, it can be any sort of custom stack, and you may do that entire stack in the user space, but when it comes to developing something like that, you need to do on a system which doesn't intercept, and it doesn't stop this packets getting processed. So if you enable if you run this stack, and if you just send this packet, what happens is you may get these packets into the OS layer, the Linux kernel, and the Linux kernel will take these packets and it may drop, and it can cause any sort of issues. So you need to have some mechanism to bypass. But on the other side, in case if you have bypassed the same, with raw sockets you can anyway deal everything in the user space without any kernel's intervention. We just need the kernel to do the core services of the packets in terms of getting the packets via device drivers. And the same way, when you send any packets from user space to the kernel space, the kernel have to send these packets onto the wire of the NIC card through the device driver. So that's the scope of it. So it is quite important. You should learn about promiscuous mode. I get shocked. I do have students who are into networking and stuff, but they never have explored promiscuous mode. So if you have not familiar yourself, this is the episode for you. So promiscuous mode is quite useful if you are doing apart from this, if you are doing any type of custom research or something like that. In fact, if you ask me, I was trying to do some application layer protocol without using Ethernet header, IPv4 and TCP or UDP. I want a direct application layer working without any sort of low level network layers actually. Okay, so this is something often I discussed. The OSI model or whatever it is, it's just garbage when it comes to the real world. Sometimes you may have a real world situation where you can break the rules, and in terms of breaking the rules, first you should be a master and learn the rules, and then you can think about breaking the rules. Okay, so sometime earlier I have even done a video about the same. You may have a layer 3, and on top of layer 4 again you may have layer 3 headers and stuff when you do something like tunneling, VPN and stuff. So when you do any tunneling, what happens is you are adding extra v4 headers. You can send IP underscore IP within that IP under an IP, or IPv6 within IPv4, IPv4 encapsulating IPv6, or on IPv6 you can send IPv4. Any scenarios are there, and sometimes I even seen you can send layer 2 services you can offer on UDP or stuff like that. So anything is possible. So when you do that, it can also be a possibility that you don't use any of these layers, and you can directly use application layer directly. Okay, so this is an attempt. So I did a very small sample code. In fact, this is the code I have discussed. I was discussing with my students. I don't go much in depth about what is the overall discussion context, because that is something else. As a part, I was discussing this as a sample. So if you come here, this code I picked up from my own code. You can see here I did some series of episodes long back as a part of raw sockets. You can see here I did this quick protocol packets, which is on top of UDP, and below that you have this VoIP and stuff like that, and much below that it has this I have done this HTTP and OSPF and stuff. So you can get back, you can go back here, you can see here quick packet. So I picked the same code, I have removed some of the portions, all these portions, and I have stripped down everything and I just did a code like this. So the objective is to send an application layer without any low level layer. So that's the overall objective of this. You can see here in the code I'm picking a 1600 byte buffer. So initially I'm doing a mem setting of this entire buffer with the zeros, and I'm setting this first 3 bytes with some custom application layer protocol. So you can imagine this is something once long back I discussed about writing your own network protocol, how you can design a network protocol. So as a example model, what I have done is these 3 bytes constitute a protocol definition, where it can be a 3 byte protocol. The first byte will have some operator or operand, whatever you call. So it may have value like plus, minus, division, equal to, multiplication and stuff. So after that it can have some value 1 and value 2 as its fields. So that is what is happening. I'm using this 2b. 2b is nothing but the ASCII value of plus symbol. So this is nothing but a plus, and then it has after that it has 2 values. So you send this from one machine to other machine, and then the other machine can take this, parse this, and then it can send some reply with something like equal to, it can put here, and then it can put 9 or something like that. Okay, so something like that. You can even do this if you don't want. You can even do this way also. It just how you code or your coding discipline, it changes. So you can either do that way, or you can do it much simpler or intuitive this way. Doesn't matter. In any case, it is going to be the same value in the binary format. Okay. So after that, you can see here I'm doing a create socket, and this is my abstract API which I have done for that video series. So this contains all the logic to create a raw socket. So below that you can see here I'm doing the write operation, and I'm capturing the return, and then I'm displaying the same. So for some reason, if I send this frame which contains less than 14 bytes because of the Ethernet standard, it is not going to send the frame and it is going to fail. So for that reason, what I have done is I have enabled this 14 bytes. So technically all I need is this 3 bytes to transfer. The rest of the bytes I don't care. So the rest of the bytes out of that 14 bytes, it's like a don't care. It is going to have value of zeros, as you can see, because I'm doing a mem setting of that entire buffer with zeros. So this is what is the code. It's very simple. As you see here, unlike your standard frames you capture in Wireshark, there is no Ethernet header, there is no IP header, no nonsense actually. So there is nothing like that. And this itself is a best example of application layer protocol. You can see here, this is what an application layer protocol looks like. Okay, you are sending something, and then from the remote end it can parse this, it can transfer its reply back to you. So this is what I don't have to discuss that, because I have discussed earlier in some episode. Okay, long back I have discussed in some episode how to create a protocol, something like that. Okay, so let me scroll it down. Hope I can catch that episode. So somewhere I have yeah, you can see here, this is the episode. Okay, 339. Maybe I can add this in the references as a part of video description, so that if you are interested you can just pick and then have a look. Okay, so coming back to the topic, the main objective of this video is about promiscuous mode. So I can't demonstrate with this bunch of laptops, or this laptop and that PC. It is very cumbersome to record. So what I did is I picked up my VM machines in my virtual lab. So this is more than enough to illustrate this. And please note, although it is on a VM, don't get confused. This is how in a real world also it is going to work. One thing is, this has been virtualized and it is in that virtual network, whatever I have put things. But in the real world, you imagine I have this, 2 VMs fired up. See, you can see here, this is one Manjaro Linux desktop. This is another Manjaro Linux desktop. And both of them are connected to the LAN port of this pfSense router. Okay, so you can see here this is running, and I have these two desktops which are, desktop VMs which are running. So you can see here its network, this VM network and this VM network are connected to this one of the port of this pfSense router. So just imagine two systems which are connected. Okay, in case if you have Raspberry Pi, you can do this experiment. In case if you have couple of laptops, your laptop and your friend laptop, you can even do the same experiment without any VMs. Okay, so as a demonstration purpose, I have the same. Let us just quickly boot into this one of the desktops, or else both of them. Okay, so what I did is, before shooting this video, I just compiled this quick.c. Although the name is misleading, it is no more any quick. Okay, so anyway, it has the name quick. So you can see here I compiled and I copied in one of the VMs. Okay, the other VM, what we can do is we can fire up, and we can set its promiscuous mode. You can see here this is the network port. Don't get confused. This is a question I got from a student yesterday. Is it something, this port is a virtual port, something? He got confused because it's on a VM. Not to get confused, because the operating system, whatever this Manjaro Linux sees this port, it sees like any other network port. It doesn't know that whether it is virtual or physical hardware. It is fully emulated by VirtualBox. Okay, so it is fully emulated by VirtualBox. You can even go to the settings, go to network, and then go to advanced, and you can see it is virtualized network adapter. You can see here the adapter model is 82540EM Intel Pro 1000 MT desktop, something like that. Okay, so it's just the operating system which is running, it really doesn't know any difference between a physical one or a virtual one. Okay, so this is what, so that's the beauty of virtualization. Okay, so what we do is we enable promiscuous mode on this port. So if config enp0 s8 promisc, and if I do if config, you should see this promisc getting displayed. So what we do is we fire up Wireshark sudo Wireshark gtk, and we capture this port, and we go to this Manjaro desktop, the other one, and we do send a sample packet enp0 s8 from this desktop to the other desktop. Okay, so once you do the same, see, you can see here ret equal to 40, its return is 14 bytes. So which means the write API is successful. You can see the code, the write API is successful. So we can go to this Wireshark and we can analyze. Let me stop this capture, and we should able to get that, catch that frame. Yeah, you can see here we caught this frame, and you can see here the frame, the Wireshark thinks it is having Ethernet header and something like that. So it is displaying all this, and since it contains everything zeros after that, it is showing the type of this Ethernet as unknown. Okay, of that Ethernet header is unknown. In fact, in reality, we don't have any Ethernet header at all. Okay, it's just a brute force way. I am trying to write an application layer protocol without any layer 2 headers, nothing. Okay, this is what. So it is directly putting over here, and it is sent. And in case if you don't trust me, we can also do one more silly experiment. We can pick this entire buffer of this quick, the hard coded one, and we can copy, and we can copy in this code, and we can dump it. If you watch my episode, you will understand this is the application part of that quick sample packet, and this is the layer 2 header and the IP header I'm generating. Once it is all generated, you can see here I'm doing a mem copy of layer 2 IP and the quick everything, and then cramming it and then sending that valid UDP test packet with application layer and all the layers intact. So we can even do that, and we can fire this entire 631 bytes. Instead of this, even if you want, we can do this itself. Okay, we can do quick, and then we can copy this. Instead of 14 bytes, it is around 631 bytes. So you can see it is having this buffer is starting with this UDP header and then this contents, the application layer. So we need to do one hack. The UDP header is around 2, 3, 4, 5, 6, 8 bytes. So what we do is we can just do one small hack, quick plus 8, okay, and 631 minus 8 bytes. So we just make sure it is only sent application layer of that UDP alone, and we don't send the other parts. Okay, so this way we are sending the application layer on top of UDP as it is, without any layer to header and IP header and stuff. So this is what constitutes a research like Promiscuous mode and raw sockets. It enables you to write your own protocol stack, let it be lower level protocols, let it be higher level protocols, or any sort of experimental stuff. So it gives that superior control. Okay, so what we do is we just copy it here and we just compile the same. Okay, so you can see it is compiled, and we can move this quick as quick 2, and we just copy into this Manjaro Linux. Okay, SCP Kiran at 192.168.0.88 to NAS quick 2 dot. So let's copy the same. Yeah, you can see it is copied, and we can run this. Before that, we run this Wireshark, and we can run sudo quick2. Yeah, you can see 623 bytes, and if you go here, you should see this frame being generated. And once again, Wireshark is confused. It is trying to parse this, and it is assuming this is the destination MAC, source MAC, but in reality there is nothing like that. We are sending directly application layer. So in case you have done a proper raw socket code, you receive that, and then if you written all the parsers, if you do a read operation with your custom raw socket code, and you have done all that operations, you can, in theory, you can process this application layer, and then you can send a reply custom cooked application application packet as a part of its reply. So all this magic is possible, and all this is possible because you enable the Promiscuous mode. See, in a NIC card, if you don't enable the Promiscuous mode, the NIC card will have the MAC address, the hardware address. Say for instance, this NIC card has this MAC address of 0050 B6, something like that. So in this case, this virtual NIC card, whatever it has in the VM, it has this MAC address of 080027 and stuff. See, any frame comes which is not matching this MAC address, it is going to be discarded by the NIC card itself. And in order to allow that to happen, you need to enable the Promiscuous mode, then only it is going to enable. So in case if you are using Wireshark, just a quick tip, okay, not Wireshark, in case if you are using VirtualBox, important tip, in the settings, okay, you have to mention here allow Promiscuous, allow all. Okay, if you don't do that, even though you do in the operating system like I have done here, it is not going to allow it. Okay, so be very cautious. Although you have done the promise command, although you have done here, without enabling this, it is not going to do support at all. And sometimes I also see that even giving this is optional, because once you provide promise mode allow all, most probably I don't think so it is even required, because the NIC card itself is set hard coded to accept all the frames in the Promiscuous mode. So this is what it is. But if you are using a laptop, not any VM, then you just need to do this, and it will work as per the specs, as per the standards. But you can tinker around and you can hack in the software layer just the way I showed. It is not always necessary that you need to use all the layers of whatever nonsense they discuss in the OSI model. It is needed as a part of compliance, it is needed as a part of interoperability. Of course, you can't generate something, get some frame or something like this and send it across in internet. Of course, okay, you need a proper IPv4 and then a transport layer and stuff like that. But in case if you have a lab, if you have something like a peer-to-peer, point-to-point connected devices, you can emulate USB on Ethernet. Okay, you can emulate such things. Okay, so you can do any custom protocol, you can fire the application layer protocol without any transport layer. You can do get away with sockets with transport services like TCP, UDP, and then you can jump and do such trickery. So this is not meant for beginners. If you are a beginner, just I know that there are several things you may not understand. This is not really meant for beginners to break your head and understand. So if you are a beginner, all you can understand is promiscuous mode allows you to get any type of frames. The NIC card will not discard. If the promiscuous mode, trust me, if the promiscuous mode is not enabled, it is not going to accept this type of bogus frame at all, because you can see here it starts with this byte 00386 and stuff, which this buffer starts over here. As you can see, we have offsetted with 8 bytes. So it has skipped the first 8 bytes. So quick plus 8 and 631 minus 8. And so it started from 00386 the way we have done in the code. So if you see here, this is not any destination MAC which it matches over here, which means it is going to discard this frame in the hardware itself. So in order to enable that, you need to enable the promiscuous mode, and the main implication of promiscuous mode is to do so much magic as a part of research and as a part of learning curve. Beginner, you may not do much, but once you get into advanced level, you can write a highly full-fledged network stack all in the user space and leverage this promiscuous mode, and you can do wonders with that. Okay, this is what. So again, I'm saying, as a beginner, you may still scratch your head, you may not understand what is the true implication. So it is you can do some minor experiments, but trust me, I have seen many companies, they may have any custom network stack, they do modeling of that network stack in the user space. All they need is some type of layer to test their stack. They can do within local system itself. So for that testing purpose, let's suppose this is any slow protocol, this is something like a custom routing protocol or something. You, as a namesake, you can send this via UDP also, you can send this via TCP also, or you can send it without any aid through this type of raw sockets also, and then you can do the entire framework by yourself. Let's suppose you are writing your own TCP, you have your own TCP stack, a proprietary paid TCP IP stack. You don't need to use the kernel's TCP IP stack, and you need to test your TCP stack. Then you need some platform like this, and in the user space you can have a TCP stack and write several libraries to support your applications to use this TCP stack, and then the TCP stack should work somehow using raw sockets. It can send and receive packets. All you just need is somehow you need to send and receive the packets to that TCP stack which is existing in the user space, and you can play around with that. See, this is not something which sounds sort of interesting in a world like Linux, because always you imagine that TCP is free, Linux kernel is free, and why do I need something like that? See, this is not the case. If you have a microkernel, sometimes the microkernel, whatever the manufacturer offers, may not have all the services, it may not have all the components, it may not even have any network components. So some other company may do its network components, and they may give it as a paid add-on. Okay, so let's imagine we had the Symbian OS, okay, which Nokia uses. So I assume it is microkernel. So let's assume the Symbian provides the microkernel, but it is not providing any network stack with that. So some company is offering the network stack. You can buy that network stack, and that is going to work on top of this Symbian OS. since it's a microkernel architecture, it is going to work in semi-user space or user space. So you need some type of IPC and some type of libraries to connect to the same and use. So in such cases, every line of code you get externally, it's a paid code, not like Linux ecosystem. So there it is a complete different thing. So as you work in the companies, as you work in the industries, you will come to know, you will get exposed to all these situations. As a student, you may imagine, okay, this is something free. Even if I need Windows, maybe I can pirate and use, but that is not the way it works in the real world, in the industrial aspect. So if you see the main industry, there are many companies who do the stack alone and then they sell the stack, and the other companies need, before even they buy that, they need some prototyping. They use some platform like this and then they show the demo prototyping and stuff, and based on that they buy the stack, and then they charge for any integration services. Note, sometimes the stack may be even OS independent stack. If you have your own microkernel of your architecture, your proprietary microkernel, you can pay money, buy the stack, and then you can ask them to port for you, or you can port yourself if they expose those abstract APIs and stuff. So this is what this is how the industry works. Okay, so this is what, and even as a part of consulting, say for instance, I was doing some application layer protocol, and I was communicating, I need just a simple IPC to control some daemon with some other daemon. So I hijacked a code and I was doing my own custom application layer protocol. But if I choose, I can even ditch the UDP layer. I can use directly some architecture like this, because in my situation I'm doing local host to local host, the loopback interface. I don't even need any port, or how to say, I don't even need any IP address and stuff like that. I can even get away with that. Or if not, worst case, I can just ditch this entire stuff and start using the message queues and stuff. So this is something always, as I cover in my videos, part I discuss for beginners, but as a beginner everything is new to you. You need to start somewhere and then to get into this level, and once you are into some intermediate level, these concepts is going to help you. Once you are done with this, then it comes to a question of you being a deciding factor as an architect or something. Then you have some liberty to choose which way to go around for various reasons. Sometimes you need to choose some option for optimizing performance. Sometimes you need to choose because of some other reason. Sometimes it may be due to business aspects. Sometimes it may be vendor lock-ins. To avoid vendor lock-ins, you need to do in a different way. So all these things are possible. So if you are a very core developer, some aspects what I said is going to be useful for you. And if you are part into architecting stuff, and if you are into business aspects, if you are also doing some type of business analysis and as well as tech manager or director or something, even for them this is going to be useful, because this is a very much deciding factor. Sometimes for the reasons of business licenses and other stuff, they do need to do things workaround, and sometimes they may have custom stack, but they pay money and they need to buy that stack. Although they have a test demo version, they may do some prototyping like this, but end of the day they pay money and get it integrated within their products. So hope you learned something new and interesting. Like all my videos, in fact I got a question in a comment. Someone asked me why my videos are long or something like that. So I just mentioned I don't want to teach, or I don't want to discuss stuff like some type of kid programmer or something like that. Just talk about some basics and some garbage. I am an architect, I am a consultant, as a part of my first priority is considered, and I am not any full-time teacher or something. I just teach as a hobby, but at the same time I do consult with companies, I do work as an architect. So I need to bring this baggage and show that full picture. So there is no point showing one demo or showing some code or something like that. I need to, if I discuss something, until I discuss all the aspects, I don't like sharing any sort of knowledge in a knowledge sharing platform like YouTube. So that's why my videos are going to be long. Let it be sometimes a career based discussion. I have to discuss about all the aspects, otherwise I'm not interested to take any sort of videos. So of course my videos are going to be long as usual, but at the same time I make an effort that I cover each and every aspect, why it is so and so, its background and what is its true potential, and to make you understand I may do some type of very quick demo so that you can get some kind of idea about the same. Having said that, if you think about, this is nothing compared to any sessions I do with my students. I do discuss even more lot of things, just not about this. So it's just a very small fragment what I had a session with my student yesterday, but I felt Promiscuous mode is interesting to discuss, and you couple this with raw sockets makes it even more interesting. The possibilities are infinite, and that's what inspired me to shoot this episode. So if you have anything to discuss, be in touch via mail, and if you have anything to discuss very deep, okay, I suggest you to join for class, because it is not something I can cover in one email or one comment or something. You have to have some background to arrive at some point. So in such situations I highly recommend you to join for a class and learn several things and do research, and as a part of contributing yourself in the research, you will end up learning several things by yourself, and you will get to that deeper context of how things are interconnected and how you can leverage and use it for your full potential. Okay, so hope you like this video. If you have anything to discuss, as I said, be in touch via mail or send an email. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.